Hello and welcome to today's Teardown Sessions from Crowd Supply. My name is Helen Leigh and I am your host today. We're going to be talking with Eugene from StereoPi today, and we've got some exciting giveaways too. So let me tell you about those before we kick off. First of all, we have our usual teardown box full of mystery hardware and little bits of swag, which you can win by commenting and asking questions. If your comment or question comes in at around the closest to the timestamp that I've written down in my notepad, then you will win this piece of hardware. There is a second timestamp this week, though, because we're giving away a StereoPi Slim Edition, thanks to our sponsors, Xilinx, AMD, who are doing some really cool stuff. Let me just, before I bring Eugene on, I just wanted to give a little shout out for AMD Xilinx. If you're building anything with a Xilinx FPGA and you're thinking about bringing it to market, this is a really great program that gives you money off of your crowdfunding campaign. Also gives you all sorts of really interesting pieces of hardware and so stuff. So if you are thinking about making something with an AMD Xilinx FPGA, please consider being part of the supplier marketing program. So that's a big shout out there to AMD. So without further ado, I would like to bring on my guest today, Eugene. Hello. Eugene. Thanks for joining us. Hi. So to start off with, can you please introduce yourself to the viewers and tell us what you do?
Yes, I'm a programmer and a hardware designer, and one of my latest hobbies is a stereoscopic vision. So to have a chance to play with it in full time and in full force, I decided to create our own tool to work with this. And as a base, I choose the RaspberryPi ecosystem. And luckily, we have a compute module 4 thing, which allows us to be as flexible as we wish. So finally, we created this piece of hardware. This is a StereoPi board. So to say briefly, it has a Raspberry Pi CM4 as a main brain, and it allows you to connect two cameras to get the video or still images from them simultaneously. You see, this allows StereoPi. There's an assembled version with two cameras and CM4. This allows the system to see the world like a human see, using two eyes. And we can use this feature in two directions. The first one is computer vision, for example, OpenCV, depth map, distance estimation, and so on. And the second popular scope is stereoscopic photo and video, and the very popular thing now, VR. So you can do a first steps and understand how it works. What's the panoramic video? What's the VR video? What's the difference between the plain video and VR, and so on. That's the brief information.
So let's take a step back here and imagine I've never heard of it before. Tell me what stereoscopic imaging is.
So stereoscopic imaging is capturing two images from a slightly different position of cameras. For example, when you look at some object, the image captured by your left eye and right eye are slightly different. So your brain uses this information to reproduce the 3D world, understand the distance, and use a lot of other tricks. So this solution allows us to use exactly the same approach, and we're taking two images from both cameras at the same moment of time. That's why we can play with them later by software or by streaming it to a VR helmet like Oculus.
And how long have you been working in stereoscopic imaging? What brought you to it?
You see, why originally our focus was drones and live stream from drones.
Oh.
So low latency live stream. But at some point, we understand that stereoscopic imaging can give us a lot of advantages, and we can take more from video in comparison with just viewing it. So that's why we focused on this scope. The first idea was like 5 or 6 years ago. A few years ago, we created the StereoPi first edition based on CM3, and now we created the latest version based on CM4 because it's more powerful and This model has a lot of features like built-in Wi-Fi, Bluetooth, and much more computational power, so we can do better and faster algorithms in calculations.
Or theoretically, I'm still waiting for my CM4.
Yes, this is a rare thing. You see, we were lucky that we asked Raspberry Pi to help us with this. It was long ago, and also we're connected with official Raspberry Pi reseller in United States, the Pi Shop. So where now our project is a part of this team. So we have a secret stock of these items. That's why you still can find StereoPi camera kits, which includes also cameras, CM4, and all you need to assemble the solution.
Fantastic. So you were telling me a little bit earlier about some of the range of your devices, and I wonder if you could take us through some of the history of your boards, some of your previous ones, and what you changed and what you're up to now. Any exciting new things?
Yes, I'm looking for the previous solution right now. Okay, I was not ready for the previous edition, but I can tell you about our current line. 1 second, by the way.
Well, while you're looking for those, I'm going to see who's in the chat saying hello to us. So we've got Haywire, who's hi chat. Hi, nice to see you. He says that he's a web dev prob and hardware happiest. This is my first year using Python in production. Good experience, considering use for Tableau. We've also got Trevor Flowers in the house, who's come to say hi. Hi, thank you for joining us. Leon and Navi is another one of our open hardware creators at Crowd Supply. He's made all sorts of interesting things. Nice to see you, Leon. Thanks for coming along. And Taki as well is in the house. Hi, nice to see you all. If you are out there, please do say hi. It makes us feel less like we're shouting into the void. And you might win hardware. So please keep your questions and comments coming and keep us company. So carry on, Eugene. The floor is yours.
Yes, the brief history is our first version was based on Compute Module 3. It has this form factor and requires a lot of hardware things to implement on the board to force it work, like advanced power and so on. The modern solution is based on CM4. And we were really happy when Raspberry Pi introduced this board because, to say briefly, this is the Raspberry Pi 4 without external connections. So we were able to just add the things we need to get cameras, Wi-Fi, Bluetooth, and a lot of like Ethernet and a lot of our other features. As for the board lines, you mentioned that today you have StereoPi Slim as a present, and I'd like to highlight the difference between the regular board and Slim board. You see, a regular board is a great tool for prototyping, so it has full-size Ethernet connectors, USB connectors, and GPIO like Raspberry Pi 4. But if you'd like to put this device in a tight space, a drone or on a robot, you'd like to remove this bulky connection to get the smaller device. That's why we designed this StereoPi Slim. And by the way, due to shortage, we even considered to stop production, but we were able to remove a couple of chips responsible for advanced power supply and release the StereoPi Red version. That's the Red Slim edition. So it works exactly like the black version, but it has no advanced powering during using the additional connector. So it works like Raspberry Pi 4. You connect USB-C and it's powered on. And
did I hear correctly that you redesigned that because of the chip shortage? So you couldn't get a number of the parts that you were using for the Slim. So which parts did you switch out? I'm curious to know what you could not obtain.
It's a couple of Texas Instrument chips. So one was responsible for the real-time power switch between USB-C and additional power, and another chip was responsible for the advanced power switch. So we have 2 GPIO pins, and you can connect them using even tiny wire or use external GPIO signal to enable power or disable power. So the red version has now these 2 features, but all other things are on their place. And if we're talking about line, a couple of words that a lot of users trying to assemble the solution. So our kit includes the plastic boards and so on. But in this case, it's hard to ideally align cameras. You see, it's plastic screws and so on. And this is especially hard when you're working with the Raspberry Pi HQ camera, which can have, for example, this kind of lenses. One such lens weighs 175 grams, so it's extremely heavy. That's why we created the fully metal solution. So it's
is that milled?
Aluminum. Yes, it's advanced. It includes advanced camera adjustment, and also you can just connect it to the tripod.
Oh, nice.
Yes,
I like that.
So that's the main line of our products. The very popular question: are we planning to create a standalone assembled device? So we're not announced this yet, but yes, we're working on this. So we'll have, this is a secret information. It's an early prototype.
It's not secret anymore.
We're working on the metal face for smaller cameras. So these small cameras. So this thing will be finally metal with StereoPi inside. This possibly we'll use a slim version with cameras included Wi-Fi and plastic case. So you'll have not a DIY solution, but a hackable solution. So you can disassemble it, use your own software, and so on. So that's our current aim, and we're working hard to bring this to life.
Very cool. Got some comments here from Haywire saying very nice, and Trevor saying yay, which came just after you said about the standalone camera. We've also got Martin who's here. Hello, Martin, saying nice Manfrotto tripod, by the way. It's true, it's true. And Taki said that metal bezel is cool. I fully agree. Now, I do have a question as well here. I'm sure you hear this all the time. So I know that the Pi Zero is much less capable, but can StereoPi work at all on that less expensive hardware? And I actually have another follow-up question. Does it only work with Pi, or could it work with, like, say, for example, a BeagleBoard or any other single board computer?
It's a good question. So I have two answers. The first answer is originally every chip of Raspberry Pi used on Raspberry Pi 1, 2, 3, and so on, originally it comes from the mobile phone market. And every mobile phone, as you know, has a front camera and a back main camera. So it originally supports both cameras, two cameras. But compute module is the only item which has the lines for both cameras exposed. So if you're playing with the Raspberry Pi Zero, unfortunately, you can directly connect only one camera using the fast CSI2 connection. That's the first question. And the second question is...
Just to clarify here, so it's not that the chip isn't capable of running two cameras, it's that the pin is not broken out. So you're not able to access that unless you did some like clever flywire. You'd have to hack it and be very precise. That's like a Greg Dabble job. Yeah. Okay. Carry on. Next.
Yes, Raspberry Pi decided to expose both cameras on CM3 and CM4. And the second question: why Raspberry Pi? You see, we have a lot of experience of working with a lot of chips like Allwinner, Texas Instruments, and so on. And Raspberry Pi was the only ecosystem when you have a really tiny time from idea to the solution. So it's polished, it's stable, and it saves you a lot of time. You can spend 80% of your time on creating and just 20 or 10% on debugging. But with any other chips, unfortunately, it was vice versa. So you have to spend 80% of your time on debugging and forcing things to work. And also, I was lucky to understand that I'm really getting a lot of feedback and help from the Raspberry Pi. It was extremely unusual from the top engineers. They answered all my questions and really helped on every step of the project. So it's amazing. That's why Raspberry Pi.
Really interesting. Really interesting. And what language do you tend to use? What languages do you tend to use on when you're using the Pi? How do you tend to write?
Yeah, it's a good question. You see, we can we see two groups of users. The first group is advanced users, which are using only C or assembler, a low-level, highly optimized approach, which is very hard to beginners. And these guys, as rule, they even ignores our examples because they don't know what to do. And another group is DIYers who are playing with this or trying to build the difficult prototype, but not familiar with the nuances. And so in this case, we're using Python because especially for computer vision, because it's simple, understandable, and what's the most critical, that under the hood, Python on the Raspberry Pi is using the binary files, extremely optimized for the CM4 architecture. So you have really great speed, comparable with the C++ solutions, but the simplicity of Python.
You'd say that you said the speed is similar to C++. That surprises me. I would have thought it would be a little clunkier because it's a bigger language, but that's exciting.
Yes, we have an article of comparison. So we created the same algorithm on both C++ and Python, and the speed results was surprisingly comparable.
Really fantastic. And what kind of proportion would you say that I mean, if you know this, like how many of your customers are these advanced users that use a low-level language, or versus the people who are DIYers?
It's hard to estimate for me. You see, most of advanced users are, most of the time they have no questions and don't connect to me, or connecting and say, hey, you see our drone at this speed is crashing to this tree. What's the specific feature in this situation? Do we need to use the head sync or specific features of the bus and so on? So I'm getting most of the questions I'm getting from the beginners about Python. And now we are getting a lot of questions from the other scope, from the VR. That's why we're polishing our Oculus Quest application. And we have examples for VR stereoscopic and panoramic video and so on. I hope that we will release them soon. So that's another. Yes, that's another scope when users need just a thing which they can turn on and see the result.
Very, very cool. And do you think you're going to continue with that double track of languages? Because you've got to create, I assume, example code for both of those languages when you're releasing your products.
Yes, you see, most of one of our most popular code is a StereoPi tutorial. It's published on GitHub. It's very popular and used by a lot of customers, not with the StereoPi only, because we collected all steps needed to. So it seems simple, but ideally you should test that you can capture images. Then you should take a series of images for the calibration. Then you need to process calibration. Then you need to implement this data. And then you need to understand how to get the frames in real time and show the depth map. And finally, from the depth map, you'd like to get the point cloud, that is 3D representation. So each steps are described good everywhere, but there were no full tutorial from the beginning and up to the final result. So that's our most popular code, and yes, it's mostly on Python. And another solution designed for live stream, which is using a lot of binaries. We call this project Cosmos Streamer, and this the special edition of this image is implemented for the StereoPi. So most of the code in the latest edition is binary because, for example, the things like when you are getting one video stream and you need to simultaneously stream it to 5 destination points like YouTube, another computer, a record to the file. So it's really hard to do this on Python. So you need a serious optimization, and including the GPU codes like shaders and so on for the video transformation. So these are two polarized projects. One is for digging, breaking, and playing with, and another is for real-world implementations.
Yeah, thank you for explaining that. That was very, very interesting. I wanted to say a couple of people have spoken up in the chat. We've got Shamika here. Hi, nice to see you. Saying cool stuff. Cosmo Streamer saying, shut up and take my money. Trevor Flowers saying, thank you for answering my questions. He was the person who spoke about Pi Zero. And then Taki, who said, interesting to hear how much support you got from the Raspberry Pi engineers. Yeah, it is. They've been friendly to you, huh? That's great. Lucky.
I got a lot of support to begin with. When Raspberry Pi planned to release CM4, it was even not announced. They allows me to enter the early tester program. So I
nice.
or even I have a huge article about our development, but for example, we faced some disadvantages of early access, because when we rely on the first revision of the Raspberry Pi IO board, later they changed some features, and it was really interesting when this project was updated in real time and you are updating your solution. So when Raspberry Pi announced CM4, we already have the first prototype of StereoPi 2. And so we got an access to a lot of resources. Most of our questions was related to hardware designers. Also, some CM4 features was not supported in the existing Raspberry OS versions at that point. So it was a really interesting challenge and a lot of fun and real support. So I have a lot of direct messages and emails with engineers, and they really help. Yes.
That's fantastic. Really great. I wonder, would it be possible to take a look at one in action? Is that possible? Or to have a little look at some of the code that you've written? Would you be giving us a little bit of a tour of a StereoPi?
I can. I'm not ready to run Python code right now, but I can demonstrate and maybe answer a popular question. Ask that is StereoPi is a stereoscopic camera. Can I use it as a web camera? Right? Because that's not a simple question, because you can consider StereoPi as an IP camera, so it can stream to IP address and so on. But luckily, StereoPi has HDMI output. And the simple way to turn your StereoPi into a web camera is to use this simple device, which is HDMI capture. So this tiny thing, on this side, it takes the HDMI output from the StereoPi, and this side goes directly to your computer. So I can turn this on, connect to my computer, and try to share my screen, capture the video using VLC, for example. Let me check, it should work. Yes, so let me turn on the screen share.
Yeah, turn on your screen share and I'll add it in. Here we go.
Okay, so I'm turning on a VLC and say, let's open capture device. This USB capture device is recognized as USB 3 capture. I'm just clicking OK. And right now we can see, let me decrease this window, the real-time stream from the Raspberry Pi, from the StereoPi, so I can try to direct to myself. I'm in a stereoscopic mode. If you're using Google Cardboard or VR or viewing this on phone, you can see 3D. Or if you record this video using a special option in our image and upload it to YouTube, it recognizes it as a 3D video and shows it you according to the device you are using. So if you are looking at this in Oculus Quest, it will show you the real 3D. So that's the simplest example of using the StereoPi as a stereoscopic camera connected to your computer. So you can use it in Skype, FaceTime, or any other software which is relying on the USB camera.
Very cool, very cool. I'd love at some point to see an example of a depth map as well, because I think that always blows everybody's minds. For people who haven't seen it, so haven't seen one.
Sorry,
yeah, cool.
I'm not ready to show this right now. I was not preparing.
Oh no, we don't have to show it live. We can show some pictures of it, maybe. Be cool. We could do that later.
Okay.
Yeah, that would be really cool. But so basically, I'd really like to talk to you as well a little bit about why you've chosen to release many of your devices as open source hardware. What's been your entry point into open source hardware, and why did you decide to make your own products open source?
You see, the main issue which we faced with my colleague, which helps me to design StereoPi, is we were lucky to enter the scope which actually has no affordable and comfortable solution. So our first idea was to find and buy a good stereoscopic camera, but we were able to find either expensive industrial cameras with closed code, or very cheap solutions for USB with no configuration and so on. So that's why we decided to create our own solution and show an example. And we were curious which other solutions we can see after that. And right now you can see a lot of boards based on CM4 and CM3 with 2 camera support. But until now, I see the only solution which is focused, for example, on stereoscopic video. For example, this form factor is not a random size. You can mention we have 2 camera connectors. The distance between them is 65 millimeters, which is similar and classic for the distance between human eyes. So if you are getting images on this distance, it's comfortable for you to see. Also, the positioning of connectors and other stuff is optimized to use it as a camera, but not as an early testing development board to just check how it works.
Very cool. So how did you get, did you go to college to do an engineering degree? Are you a dyed-in-the-wall electronic engineer, or did you do something? What was your path to all of this?
Yes, my education is related to radio engineering and cybernetics.
Okay.
After my graduation, I was focused mostly in other scopes like sales, business, and so on. But at some point, I decided to recall this at the beginning as a hobby, and later it turned into my main project of my life. So I'm happy that I go back to my original wish and scope of interest, that is radio engineering. You see, creating a hardware is much more fun and dangerous. It's similar to programming, but if you have an error in your code, you can release a patch, and that's fine. But if you created 1,000 of boards with a bug, you cannot do a simple patch, and that's why it's a challenge. It's interesting, and it's a bit stressful sometimes. So you have to choose appropriate music when you're doing the debugging to keep calm. Yes, but I'm always happy when it finally works, and I see how it works as intended, and I say, yes, we did it. So there's a specific pleasure of playing with it.
Is this your full-time job, by the way?
Right now,
is this your major income, or like is this a side project for you?
At the beginning, it was a side project. Now it's my full-time project, and right now I'm in a transition period because StereoPi now is a part of Pi Shop company, which is official RaspberryPi reseller, and my scope of work will be wider. So I'll create new projects, both StereoPi related and not StereoPi related. So I'll get more ideas to create, and so I'll be responsible for the chain from idea to the production. So to say briefly this scope. So yes, I can say that this is my main job, and StereoPi is a huge part of my job right now.
How did you make that switch? Because I think that's something that a lot of aspiring creators and a lot of people who are making things always want to know, like, want to hear from people who've managed to make that switch from side project all the way through to this is my major source of income and I'm making how long did that journey take you? And is there any advice that you'd offer to other engineers who are starting to make their own side project hardware?
Oh, wow, it's really hard.
That's a big question. I know, sorry.
Before StereoPi, I had a few other projects, and the main consequence or the key idea for me was never try to jump into project and start up full time if you have no financial cushion, especially if you have a family and so on. So you have to be absolutely sure and check it first. As for my story, you see, it was really fun because originally, when I created the StereoPi 1 and prepared to crowdfunding, I decided to ask RaspberryPi directly, hey guys, I need 1,000 of compute module 3. Yeah. And they asked me, where do you need them? Where do you need them? Where will you assemble your kits? And I tell them, okay, this is United States. And they told me, we have a nice partner there. This partner will help you with assembly, kitting, and so on. So they introduced me to PiShop. So we were introduced like 3 or 4 years ago. So after this, during 1 year, I supplied them with StereoPis. They helped me with all components, cameras, compute modules, assembly, kitting, and so on. And this negotiation, this interaction and cooperation during more than a year, maybe 2 years. After that, I know them great. They know me great. And we just, at some point, we discussed, they asked me, what are you doing in real life in addition to StereoPi? Are you interested for more closer cooperation? So I told yes, and this discussion, it was not fast. So we were thinking, discussing all specific of this step. But finally, I'm happy because I was able to scale the project to some serious thing. You see, from the beginning, it was just a pet project, yes, but I was able to get an experience of managing production, remote production in China. See, it's not as simple. Testing, packing, all this story with the worldwide shipping. So this experience is really painful. Luckily, crowd supply helps a lot in comparison with other, because it does not help at all.
They're like, good luck, bye.
So
we do a lot of hand holding.
To say briefly, it's a long story. It's not a one-time lucky coincidence. So it was a real work. Yes.
It's a process.
Never try to win a lottery with your project. So if you're trying to get to jump in it in full time, you have to understand and estimate all risk. For example, if in 6 months you have no money, what's the next? So you need to estimate all results for crowdfunding. You see, for my both crowdfundings, now I have 2 crowdfunding campaigns, crowd supply. I was always underestimating the target. So I set the lowest quantity, and luckily, it maybe you can consider this as promotion. When you're working with a crowd supply, you are getting access to a huge worldwide distributor called Mauser. So if your project,
for those of you that don't know, they're our parent company. So Crowd Supply is owned by Mauser. They bought us a few years back. So yeah, for those of you, no, they don't know.
You can't even understand how these push your project to the top level, because your product will be available worldwide with the 2 days delivery, with all these customs clears and so on. So it's a perfect direction to build a serious project from your idea. So from idea up to worldwide distribution, that's really great. So right now, in addition to Mauser, I have access to a group of friendly Raspberry Pi resellers due to PiShop.us, because as friends, they are sharing their stock. That's why StereoPi is now available at the Pi Hat, Pi Moroni, and so on. So
I love Pi Moroni. They're so lovely.
So that's my story. And so yes, the crowd supply is the best to run your project from scratch, especially if it's hardware focused.
We didn't tell him to say this, by the way. So this is very nice. I'm appreciative of all of that praise. Yeah, I do feel like the distribution side and the fact that Mauser continue to purchase your products is actually a big deal for creators, but not one that a lot of people know about, actually. I would just say, and there's a couple of comments here. We've got, Martin has pointed us to an OpenCV and depth map tutorial on the StereoPi website, which I actually have. That's what I was doing, typing away there in a minute in between, and was bringing up that tutorial. So I might have to have a look at it so that people can can see what we're talking about. And we've got Haywire saying, very cool. I've written one app for Oculus, and this opens up lots of application ideas. Very cool. Annalene's in the house saying hi. She's from the Pi Shop supporting team. Hi, Annalene. Thank you for joining us. Also, Martin is that as well. And Haywire, his future supporting team. And with that message, you win. You were the closest to my timestamp, so you win the StereoPi Slim edition, Haywire. So if you send me a direct message on Twitter, either at CrowdSupply or at Helen Leigh, you can send me your address and I will get this sent out to you in the next week or so. So that's this. We still do have our mystery hardware box to win, so please keep your comments and questions coming in. But yes, congratulations, Haywire. Send me your details and we'll send you that out. Very exciting. We also have Cosmo Streamer who says they're a StereoPi supporting man, the best kind of man. Good job, Cosmo Streamer. We like it. And Taki B says it's very interesting to listen to these aspects of your activities, Eugene. I agree. I don't think we talk enough about, we talk about technologies and the technical details, but it's really interesting to hear the business side of things and how people manage to make it work and how they built their stuff. Very interesting. A few more comments here. We got another Haywire saying, "Oh, you grew up in the town of Mauser Electronics HQ. How funny! That's nice." And then lots of congratulations there for the winning of the thing. Very cool. So, Eugene, would you be up? If I share this screen with the OpenCV and depth map, would you be up for talking us through it a little bit? Because I think it's a really exciting use case.
Yes, yeah, I think it's better to share let me share.
Which one would you like to share?
It's better to take.
I can share anything.
Could you please open the blog and find an article? Yes, it's the top right link, blog.
Yeah, got it. Blog.
And scroll down a bit, and you'll find an article of comparison of Python and OpenCV. So this the best screen record. Yes, that's on the
this one.
OpenCV. Yes. So
here we go. Oh yes, interesting.
You can bet a few videos. The screenshot shows the result. If you scroll it, it's like first, second, third, fourth. Let me find the step. Calibration. Tuning.
This is excellent documentation. Do you write all of this yourself?
Yes, it takes a lot of time. It's like step six.
Look at all of this. This is incredible. I'm very impressed with your documentation here. This must take longer than the code. Or are you a natural writer?
Yes. So if you play this video, this is the screen record of Raspberry Pi during this experiment. So this code shows undistorted images. You can scroll like at the middle or at the end of this video. So this guide is a step-by-step recording what should you start to get the result, because it was my pain when I read other tutorials. So I try to describe everything from scratch, where to click, what to press.
Wow, that looks so cool.
So on the right, you can see two black and white images, and on the left is this is a depth map. So with it's colorized, you can adjust the colorized parameters. And if you scroll down, you can fix. Yes, I'm explaining how to fix this jumping color problem.
Oh, I see. And then you want to scroll down to another step.
Yes. You can scroll the next video with the C++ example. It's the
same nice.
Example,
yes.
But built on C++, so it has less parameters. And this tutorial, yes, we did this. You see, preparing the full working environment for C++ compilation is a hard job. That's why we created the pre-cooked Raspberry Pi image, Raspberry Pi OS, so you can just load it and play with the code. So here at the, let me scroll at my side. It's like, yes, it's just 1 minute length.
Yes. So here's the depth map on the
Yes. This is the depth map. So it's the same place. And you see this in this example, I was using not the regular camera, but a wide-angle camera, fisheye cameras. So you on the right, you can see that it sees not the regular angle, but wider angle. And this is a good example when you are doing a drone, which you have to see as much as possible. The higher field of view, the better.
Very cool. So LiDAR mode, tell me, well, that's very exciting. So tell me a little bit about LiDAR. You've got so much functionality with this. So what would you be using here? This is a 2D map from the depth map.
Yes, it was my first attempt to show how you can use 3D map, but not the point cloud, because point cloud is a huge amount of data, which is hard to process on the Raspberry Pi. And in this example, I was showing that you can use StereoPi as a radar. So you have a 2D map of obstacles. So it was using just a middle size of the middle part of the depth map. And on the blue rectangle, you can see the contours of obstacles as a group of points. So it was the very simple implementation, which you can use on your robot out of the box. Just choose the part of the image you'd like to use. And this is very simple to use inside Python, even if you are not an advanced programmer. Yeah.
Very cool. So, thank you for taking us through that. Is there anything else you'd like us to actually, there was a UV thing on the beginning of the block. What's this?
Yes.
That's fun.
Actually, StereoPi has a few hidden features.
Tell me about your hidden features.
Actually, RaspberryPi camera also has a lot of hidden features. For example, if we're talking about the HQ camera, so originally you can see the optical image like any camera, but the sensor, Sony sensor used in this camera, actually can see both infrared and ultraviolet spectrum. And to cut them off, they're using a special infrared filter. So actually there are two filters. One is installed on this metal part and another is sticked on the sensor. So some advanced group of users are doing tweaks of these cameras. They are removing all filters. And after that, you can see the world in ultraviolet. On this image, you can see the photo on the left is in a visible spectrum. And on the right, this image is similar to the image visible by bees, for example. So
cool.
To simplify, when you're looking at the grass in ultraviolet, most of flowers are light, white, and extremely contrast. So, and these guys work hard. They did a lot of experience with plants, with bees, and so on. And we have a lot of ideas of projects. For example, a system which can protect bees from horns, aggressive insects, which kills the bees. But when you're looking at them in optical vision, you can see the regular picture, but in ultraviolet, you can see more and detect these enemies. So, yes,
that's really cool.
So I was happy you were asking about open source. I was happy to see a lot of implementations of StereoPi in the scopes which we were not even able to imagine that it's possible to use it there. So like deep underwater stations, which need to capture stereoscopic or spherical video, or drones, autonomic drones. I'm still excited by the solution. So it's based on StereoPi with moving cameras. So you can change the stereoscopic base, for example, to estimate the distance for objects like 2 meters from you, or to objects like 100 meters from you. So it's a lot of implementations.
Very cool. Actually, that dovetails neatly into the next question that I was going to ask you, which was if you could tell us about some of your favorite implementations and the favorite projects that you've seen from the community that they've been making with your things.
Well, one of the most bright project is the third-person view of yourself. So we did this as a toy. In this situation, by the way, you can see you can find this in our blog.
I'll find Leigh. I'll go back to it. Yeah, I'd be curious to see that.
Yes. So the idea is StereoPi is set at your back, and you can see yourself. Yes, to the bottom right.
This one? No.
No.
This one.
No.
The VR heads.
No, it's not.
Oh, just keep going.
Maybe yes, I need to find the link to this video. Yes, please open the link about DIY helmet, and one image will explain a lot. Yes.
The DIY helmet. Which one? Did I scroll past it again? You mean the headset or the horse helmet?
View from third-person view is the very bottom at the
right. Right at the bottom.
Yes, right bottom.
Oh, here, yes, right at the bottom.
Yes. So
yes,
the first image will explain a lot. You see this girl on the floor. So she's in Oculus Go, and at the back you can see a special device, and at the top of them it's a tiny StereoPi. So she sees the world only using StereoPi. If you scroll down, you can see a video like a few minutes, and it was extremely crazy.
So cool! Oh my goodness!
They were trying to take objects, to dance, to move. So it's like you're playing in a game, but your hero is yourself. It's extremely unusual experience. Yeah, so that it was
super unusual.
Related to VR.
That's so cool.
Another project is which I was inspired is unusual implementation. Also, one guy has a task about controlling the 3D environment of some special room with equipment, and they were not interested in capturing this in real time. It was fine to take one stereoscopic image once per minute, but it was a huge resolution, like 12 megapixels. And they were building the depth map in an extremely high resolution. And based on this, they were controlling the position of the device, because this room was set on the top on a secret device. It was moving. It was a lot of potential problems related with this. Yes, in this experiment, it's also fun. In this experience, the author tried to model the horse vision. You see, because horse can see the red light. By the way, when you see a tiger, for us it's bright, but for a horse, it's not bright, because orange lines looks like white yellow for the horse. That's why the tiger is not contrast. So in this experiment, as you can scroll down and see the comparison of the image seen by horse and by man, it's really. Oh no, maybe it's not in this. Yes, I need to send that direct link. So the comparison images shows that horse see the world in absolutely another representation. Also, we try to emulate the chameleon vision. So when your eyes not parallel but moving, but we got nothing but pain in your eyes. So
very cool. Some amazing. I'd never have thought of horse vision. What a wonderful project. Very, very cool.
Yes, specific of horse vision is that horse eyes are not parallel. They're looking at sides, but they have a 3D vision in very narrow space ahead. So it horse feels the direction and volume of all objects in front of itself. But on the left and the right, the horse just see the object using one eye.
So interesting. So interesting. And the VR helmet as well. Really cool. Really cool. Nice. Okay, let's go back to the comments. Let's see who's saying things. We've got Haywire saying, really looking forward to working with the tech. I'm looking forward to getting it out to you. Taki B said that the good documentation was the reason why I crowdfunded StereoPi V1. And I think Taki raises a really good point here. I think a lot of people love StereoPi for its extremely extensive documentation. If you were here with us earlier when we had a little look through their video that Eugene made, it was even went down to like what folder you should click on first and what problems you might run into. So that kind of experience opens up the ability for lots of different types of people to start using it and start making creative things with it. So yeah, I agree. Like a big shout out for your documentation ethos there. Very, very cool. And Taki also said, I still need to install one camera for a long-term experiment documenting the growth of plants, though. That sounds cool. And Taki, with that comment, you are today's winner of the mystery hardware box. Woo! Everybody loves the mystery hardware box. What's in here today? We've got, as always, an extremely fetching Mauser cap. Who doesn't want one of those? You've got a Hackaday Blinky Badge kit. You've got a SparkFun Rochambeau Gold infrared board, which is really cool. And you've also got a little proto board with some stickers and a voucher here from OshPark. So thanks to OshPark for supplying those things. And of course, some other we've got a bunch of stickers in there as well. So thank you for commenting, Taki. Please send me your details on Twitter and I will get that sent out to you today. So congratulations. You get the box as well, of course. That's the main prize. And I also got here Timonsku, who has joined us from Germany. Hello, Timonsku. Always nice to see you. Timonsku is the guy who did P Unira, which is a CM4 carrier board with the Arduino form factor. Lovely little board there. Also somebody who does good documentation. And Timon says, very cool projects. I fully agree. And Leon said, +1 for good documentation. This is definitely mandatory for building up community. Definitely. And if people have a good experience with it, they're going to tell other people. And it doesn't gather dust. So it's going to make you feel good as well. Having this documentation and the example code, it means that people can actually use it, not just buy it and then feel a bit bad about it gathering dust in their shelves. But you'd be surprised. Well, you probably won't be surprised. But, a lot of people don't put in the effort for good documentation, and it really definitely shows. So I was wondering if you might be able to tell us a little bit how you approach the documentation for the StereoPi. What's your method and what's your ethos behind it all?
That's simple. When I try to repeat or follow some other projects, in some cases I feel pain. And I was always thinking that, okay, if I'd have a detailed description step by step here, that will be great. But when I have step-by-step description for 20 pages, it's too long, it's uncomfortable. So ideally, I'd like to have a video which I can scroll and see exactly which window open, or which folder we should move, which command to run, to repeat it step by step. So that's why I try to just explain as detailed as possible to avoid any question. You see, the first aim of any DIYers is blink LED on Arduino is just to try to run and see the result, and you are happy. But with advanced systems, with a lot of features or difficult hardware, there are a lot of caveats to avoid to force it to run. That's why I try to simplify and for StereoPi to do the same. So you can just follow step by step and repeat examples first. And after that, you can update code or write your own. So I think I just try to put myself in the customer's shoes and try to not cry when I follow my own documentation. That's it.
But that's extremely thorough. So you actually go through your own documentation step by step. So you follow your own advice. And if some water escapes your eyes, it's not done yet.
Yeah.
Fantastic. Exactly. Do you work with other people at all, or are you just do you have people who will read your docs and give you feedback, or is it just you and the Raspberry Pi engineers out there doing this?
No, for my documentation, I write it without Raspberry Pi engineers. I ask my question on the forum or in the email. So I'm not asking them, hey guys, could you please write me these 10 pages? I will be pleased. No, that's not the way. But of course, I test my documentation on my friends and colleagues, which helps me. Just asking them, please read, check if it works, if it's clear, or you are able to understand it wrong and do wrong steps and get no result. And this is mandatory. It works perfect with the beginners. When I say, hey, please, are you familiar with Raspberry Pi? No. Oh, could you please follow this guide? And this explains you a lot of things.
Yeah, I mean, to be honest with you, like Raspberry Pi documentation is top notch as well. So I think by being inside of the Raspberry Pi ecosystem, you kind of have to raise your game. You know, people who are buying these things, they are expecting good documentation as a standard these days, and they're expecting it to be accessible to tinkerers as well. And like, I think that's one of the reasons why I admire the fact that you've done both C++ and Python, and that you can see that there's a very different use case for both. But it's really nice to see, and especially in collaboration with your excellent documentation. It's it's not an accident that StereoPi has become successful. You know, these kinds of things are what really sets it apart from just a random piece of hardware in the box. You know, so major props on that. How do you manage your community? So there's obviously lots of people out there. You mentioned a forum. How do you communicate with your customers?
The most technical questions are handled on forum. Unfortunately, it's a bit hard for me now, but I try to spend more time for this because why I prefer forum. When I answer on the forum, my answer and question can be seen by other people's, and this can help by just looking for forum. And for very specific requests, of course, I'm using email or a video conversation. But emails, yes, as a rule, they are used for extremely specific tasks. And as a result, most of these email threads are later turned into new articles in the Wikipedia, in our wiki, because I have a lot of useful features, as well advanced features from each email thread, and I just put it to public.
Very cool. And do you find now that you've got a slightly larger community that other community members help each other out in terms of troubleshooting or tips and so on?
Yes, yeah, I have a few guys on the forum, and I respect their help because they are answering faster than me. So sometimes I go to forum and see the question and answer from my helpers. So that's a perfect feeling that I'm not alone and they are really helping. So I'm doing my best to write the documentation and to answer question, and I'm really happy that other guys feel this and really glad to help. So it's
very cool, very cool. So we are somehow nearing the end of our hour-long stream. So I wanted to take a quick look in the comments to see this, but also Eugene, while I bring up the comments, think about if there's anything that you want to plug, if you want to tell people how to get in contact with you, any of that kind of stuff. We'll have a time to go over that. But let's take a look at some of these comments from the documents. So Leon was came with a comment saying, however, honestly, writing docs and keeping them up to date is harder than it sounds. It is. You're right. It is actually very difficult to do documentation correctly.
We're using one small trick. You see, software is always updating, and one thing which works in this version can stop working in a further version. That's why we're using the ready-to-use Raspberry Pi images. When you just load it and everything works to start your experiments. And when you're using the newer version, you have to, of course, check and fix a few things which have been changed.
Very cool. Martin says also that the best software often starts with great documentation. Use the docs as a template to build the software from. Interesting approach. Very cool. And Cosmo also agrees, saying, agree, writing docs is a hell for people who write code. There are some people who can do both. For example, Eugene here. But yes, it is sometimes the people who are great at writing code are not great at writing words to talk to other people. Lots of people liked your joke about crying about the documentation. Lots of people laughing at that. And Martin then pipes up saying, ultimately, source code is documentation. winky face. Yeah, sure. Okay, and then Cosmo said the best docs usually has a CPP file extension. All right. Leon said, Raspberry Pi has a great documentation. There are so many community resources, really awesome. And this is part of the magic. I definitely agree. And so does Martin. All right, so we are coming up on an hour. Is there anything you'd like to plug, Eugene, or tell people to watch out for? Or how can they follow you? How can they find your forums? Where can they read your blog posts?
The main place right now to get all our contacts is StereoPi.com. So on this website, you can see contacts or Telegram, a link to Twitter, and so on. So, and welcome to our forum. If you have any questions, like technical questions, or where to buy, or share your project, welcome to our forum. The link to the forum is on the StereoPi.com.
Yep, I have put that as a marquee banner underneath, just because marquee always just makes me smile. Who doesn't love a bit of marquee going across the? It's like the olden days when we all had HTML websites. So brilliant. Everyone go to StereoPi.com. And also, you heard it first here, there will be a new product coming out from StereoPi at some point, which will be some kind of standalone camera. Of course, I'm sure we're all waiting on tenterhooks for that to be ready and for you to be able to share some of more details of that. Hopefully coming soon. Very cool. Right. A couple more things before we head off. So Leon said, wow, this is great. Well done for all of the hard work for maintaining Raspberry Pi images that work out of the box. Yes, you get major props for that, maintaining something like that. And he also says, I think StereoPi is such an interesting project that it deserves a second teardown session. I agree. We can have like one teardown session for each camera. It's a stereo teardown. And he says, thank you for this live stream, +1. So I agree with Leon on everything he said, and especially, yes, thank you so much for joining us today on this live stream, Eugene. I felt like I've learned a lot about StereoPi, but also about your approach to business and your approach to documentation, which is absolutely key, I think, in the success of StereoPi. So well done, and thank you for all of your hard work creating this and maintaining it. All right, I will see everybody next week. We are chatting next week with someone with Anne from Circuit Python at Adafruit. She's going to be coming on and talking about Circuit Python, and why Adafruit is leaning so heavily now on Python. So we're going to be going on a deep dive with her next week. So please do join us for some fun Adafruit insider gossip and action. And again, thank you all for joining us this week. Don't forget, if you were one of the winners of either the StereoPi board or the mystery hardware, please make sure that you do DM me your name and address on Twitter. So please, otherwise they'll just sit gathering dust on my desk, and I don't want that for anybody. All right, so thank you so much. It's time to head off, and I'll see you next week. Bye. Bye, everyone.
Bye-bye.